All right, welcome to a Monday. We are moving on. Today we're going to do 1.9 as we go on with things here, but let's do just a little bit of housekeeping stuff here. So as far as homework is concerned, 1.6, 1.7 is going to be due today, so Monday night. 1.8 is going to be due Wednesday. 1.9 is due Friday, and sometime next week we will have an exam for the end of all chapter 1. We good? What exam it will be? I already forgot here. I think it'd be the third exam, right? Third exam? Because we did the appendix exam was one, and then half of chapter 1 was the other. Cool. Okay, any other housekeeping stuff? I think we covered everything else, right? So let's jam 1.9. Next thing we got to learn about functions. And so far we've been learning functions here. Something called the inverse function or inverse functions. It's just an operation that we do on things here. Okay. Okay, so inverse really just means going backwards. That's what it means in mathematics. So if I'm going to go forward, let's say this here. Say I'm adding a 7 to a number. We're good? What would be going backwards? Subtracting 7. Absolutely perfect. We're good? So let's write up how we actually say this here. So inverse functions here, the way we write it, first of all, we write it as like this. We write it as a function called f of x. Since we're adding 7 to a number, we write it as x plus 7. We're good? That's one way to write it. There's your function, there's your formula. All right, then what we can do is we're going to write the inverse. Now the inverse, we're running out of things we can use for notation. We good? So what we do is we put this little -1. It's not an exponent because it's a function there. We good? So it's a -1 next to the function name. And this guy means inverse.
Oh, yes, I thought it was an exponent.
So we say f inverse of x. So right here, f inverse of x. All right, so as we said already, real quick here, so adding 7 is the function. Therefore, Dylan said subtracting 7 would be the inverse. So we go x minus 7. There it is. It's undoing the work of the function. That's what we have here. Does it get more complicated? Of course it does. So first things first, that's the function notation. Let's look at a different way. Let's look at it in terms of points along a graph. So we're going to put this little something called braces because we're going to have a set of points. And so if I were to plug in, let's just do them real quick here, not too many. If I were to plug in a 1 into my function, the answer would be, if 1 goes in into my function machine, what goes out? An 8 goes out, right? Because we're adding 7 to the 1. Perfect. If I put a 2 into my function machine, 2 plus 7 would make 9. And then let's do one more here. If I plug in a 3, and we get ourselves a 10, and then let's close off our little set. And so I want you guys to sort of see what's happening here. Okay, if I reverse, oh, this is so cool. Hold on. So x goes in, y gets out, right? So how about this? This is the funniest thing. If I reverse the numbers, would it work? So if I go like this, if I plug in an 8 into my inverse function, my 8 inverse function machine is going to give me a 1 because it's going to be 8 minus 7. We good? So what an inverse does, another thing an inverse does is just switches my x's and y values from each other. That's cool. So hold on. 2 goes to 9. Therefore, 9 goes to 2. We good? 3 goes to 10 for my function machine. Therefore, 10 goes to 3 for my inverse function machine. Are we good? So put over here, switches, x's, and y's. That's what's really happening there. Boom. Okay, just sort of keep it in mind here. And then one more thing we're going to do. Let's see if it's a definition. Try to make sure that that is actually the definition. Yes, okay. So if f of x and if fx are given, chicken scratch here, let me write it a little bit bigger here so you guys can see it in the back there. So if you have a function, right, and then you have the inverse of the function, if you have both of them, if f of x and f inverse are given, then I know two things here. I know this. You guys seen those before, like last week sometime? What does that little hollow dot mean? Say again? Composed with. Remember that? Composed with? So that's one way of writing it. The other way of writing it was like this. F of f inverse of f of x is equal to x. Okay, put a big O and. We're going to get there. We're going to get somewhere here. And f inverse of f, or composed with f, is equal to x. Well, we'll figure this out in just a second here. So it looks like too many things here happening here. Okay, so if you want to write down, write down this piece here and this piece. If you want to write it down like that. So f of f inverse of x is equal to x, and f inverse of f of x equals. Next, Dylan, you had a question?
The inverse notation in the f of f minus 1, that's just for the second half, right? That's not for the entire thing?
Correct, yeah, just for the second. Okay, so now let's see. That's the definition. Let's see what it means, though. The way in algebra that we prove that two functions are inverses of each other is we do this piece right here. So if you have a function that's here, and you have another function that's going to undo the work of it, you're going to wind up back with x. Let's see if this works. Let's see. If I were to add 1, if I were to add 7 to 1, I get 8. Are we good? Then if I drop it in here, then I say 8 minus 7 gets me back to 1. Are we good? So notice those two are exactly the same. If you add 7 to a number, then you subtract 7 from a number, you're going to wind up with the original number you had with. And so that's what this says. So in mathematics, here's the way we prove it. We're going to prove that that function and that function are inverse functions of each other. We good? We got to do it both ways. So let's do it both ways here. So we say, we're going to go this. So f of f inverse of x. I think we did this earlier. Haven't we done this earlier sometime, like last week? What's my inverse function? I think it's x minus 7. Is that right?
The 7 comes from like original equation, right?
It comes right from right here. Boom. Okay, we good there? And you'll kind of see it how it all works together in just a second here. So write this with me here, because we're actually proving something here. We're proving that f and f inverse are inverse of each other. So we're plugging the x minus 7. What's my f function?
X plus 7.
X plus 7. So this guy comes in as x minus 7. And then we have a little plus 7 at the end. What's going to happen there? Yeah, these guys are just going to drop away, right? Boom. 7s cancel each other out. Do I have an X? Absolutely. Okay. Only thing in mathematics, we also have to do it the other way. Always, always. If you're going to prove that two things are inverses of each other, it has to work this way, and it also has to work the other way here. So we got to prove this one as well. And both of them have to turn out X. If they don't, then we are in trouble. All right, so F inverse of f of x, which is x plus 7. Talk to me, just making sure everybody knows where all those numbers are coming from. Okay, the F inverse function is subtract 7. And the question is, do these guys undo each other's work? Absolutely. Boom, we have proved that the two functions given on the previous slide are in fact inverses of each other. Dylan.
So I got why inside the parentheses it's x plus, or it's x plus and x minus 7, but why are you only subtracting 7 and adding 7 like after the parentheses and not adding another x plus 7?
Let's see. Let's go with it. Question is, how come I'm not adding an extra 7 in there? It's because let's go this bottom one. So f of x for us, right, is x plus 7. So what happens is that little piece goes inside here, right? Everything okay there? So then our next function is this guy, which is x minus 7. But notice what we're going to do is we're going to take this little x plus 7 and we're going to replace, anytime you see an x in here, you're going to replace that x with an x plus 7.
Oh, okay.
And so you can put even parentheses around here just to sort of see it. You can do that. And this has now changed into that. And you go from there. Good?
Yeah, so it's just like the Russian nesting doll thing.
Say again?
It's like the nesting doll.
Oh yeah, absolutely.
No
Yeah,
more nesting.
that's what we're doing.
I hate them.
Wrong.
I don't know, Ryan and I were talking about them the other night. They're scary.
Okay, let's go with this. Let's do an easy one here. Show the two functions are inverses of each other. Show the two functions are inverse of each other. Go. Landon, are we good?
Yeah.
Let's do two problems here. Let's do an easy one, then we'll work our way up to the hard one. So, dun, 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 I'm going to write this function. That'll be easy enough here. Just the easy one here. This is going to be 4 times x. Here's my first function. Is 4 times x. My second function, I have to name it a different name. But let's see, just real quick here. Show that these guys are inverses of each other. If you're multiplying by 4, what would undo that? Divided by 4. So my next function, g of x, will be x divided by 4. Easy. You can tell that those guys are going to be inverse of each other, right? But just to work it out. So just on the previous slide, we have to show. And so we're going to nest them now. So f g of x. And then on the next one, we're going to do g of f of x. And so can you work out the work for that? Just real quickly here. All right, let's see if this makes sense here. So this is going to be x over 4. That's my g function. You guys try it yourself first here just to see if it all makes sense. Okay, then when I put in my f function, it's going to be multiplying that, right? So it's going to be 4 times the multiplication of that right there. We're good? Are we okay with the 4s canceling themselves out? Love it. Those guys are gone, leaving us with 1. That's x. So going the other way now. Now f of x comes in as 4x. Good there? I think everybody's done already here. And then g of x comes in as 4x over 4. The 4's reduce themselves out, and voila. It's just like Mr. and g. I know they were the inverses of each other. Absolutely. That's no problem. Okay, let's go a little bit more tougher one. Everybody good in this one? B, can you prove to me that these two functions are inverses of each other? 5x minus 2 and g of x being, how about 5 over x plus 2? Those two, they look a little bit more weirder. Well, give you guys a little bit of time to just kind of find this yourself here. A few things to undo. All right, let me try it now. Here's so f g of x. This would be interesting. This is 5x minus plus 2. Okay, let's see if we put this in correctly. We good? So we're going to do the f function. This little x will change into our new x here. So 5 on top. And we got ourselves 5 over x plus 2 minus 2. Are we good there? I just want to see how you guys are doing here. Let me... And see if you can simplify that down. Okay. Taking it by osmosis. And then try the other way if you can. But I want you guys to try yourself. Can you get it all the way to x? This is important for you to try to get it all the way to x for yourself. Yes, that's just one. Trying to figure out that. Okay, so you want to start at 2 different spots. So would you ponder that just a little bit? You go right into x? Yeah. You will get an x on top here. The x will follow it into here, and then you put an x. So that one will be helpful. You would, yeah, that's a different way to do it. That's fine. Yeah, absolutely. That's one way to actually do. Let me show it to you, Dylan, after we finish up here. Okay, are we good there? Are we okay? Oh, you didn't check yours here.
Oh, no, you don't have to. I'm lost.
Okay, let's try it. So first things first is let's get rid of parentheses if we can, right? And it undoes its work actually pretty good. Dylan, remind me to mention that, okay? So real quick here, boom, boom, boom. So parentheses are gone. Let's see what happens here. Any multiplication that needs to happen into the parenthesis? Any distributive property? I don't think so, huh? There's no distributive property here. So see if this makes sense. It's 5 over x plus 2 minus 2. What happens to the 2's?
Well, bye-bye.
Bye-bye. So now I have a 5 on top, a 5 over x in the bottom. That's what you can multiply by x. Perfect. Okay. So 2 ways to do it here. Let's do both ways here. This way and this way, just for you guys to see it here. So one way is to sort of think about this little bar as the big bar line. We good? So really what you have is you have 5 over 1 divided by 5 over x. And that translates into 5 over 1 multiplying the reciprocal, which is x over 5. 5's are gone, we good? And we're still, when we have the x. The other way to do it, as Abe mentioned here, multiply both top and bottom by x. And if that's the case, the top becomes 5x, the bottom x's cancel, the 5's get canceled, and you're left with x. Dylan, which is very close to the way you were asking about it. Cool, guys, that's it. Are we good there? How many got that one before I got that one? How many got to x before I got to x? Okay, we gotta go the other way now. You guys go the other way. So we're gonna do g of f of x. So this one's gonna be now, let's see, g of, sorry, I'm gonna flip back and forth here just for a second here. Okay, I got this on my hands. So can you plug in 5 over x minus 2 into the g function? All right, going in here, this is x. So here's my g function. So all this stuff is going to get pushed into that little guy right there. We're good? Oh, sorry, the other way around, right? No, we're good. The g function gets pushed down. Okay, so let's see, 5 on top. All of this here in the bottom. And plus 2. Tell me if you guys are okay. Is that the way you wrote it? Good, good. Okay, so something that Abe and Dylan mentioned again here, we have a number on top, right? Which is a whole number. We have a fraction section at the bottom. So if you want to, we're going to multiply top and bottom by that same number. We're multiplying top and bottom by the denominator of our denominator. And so what happens here, these guys cancel, I'm left with 5. On top, I'm left with that right there, which is a quick way to do it. Talk to me. 5's are gone, is that right? 5's disappear. Parenthesis, no, parenthesis disappears. And I'm left with x. Boom, yes, okay, so even though they were very, very complicated, I think they were complicated stuff, they were still inverse of each other. They ended the work of the other. So let's take a look at it here. Let's see, notice, and tell me if I need to go back here. So yeah, look at this. This is, yeah, I got this little +2 here, or -2 + 2, right? And in both of them, it's kind of funny because it looks like it's dividing by 5 each time, right? But because the +2 and the -2 are in different spots, the multiplication becomes, or division comes in different spots as well. That's all. Okay, so there's that piece here. Let's jump to, so verifying inverses here. Let's go and actually graphing them. So graphing inverses. Okay, good here. So let's graph this guy. Oh, what example are we on here? We're on 2. Exercise 2, I've got one more thing to do here after that here. So exercise 2 says, graph the inverse of yeah, I don't like that one here. I think I'm going to go with 2x minus 4. I'm going to go with that one. I think that's going to work out better. So quick question is, if we did have a function, we could find the inverse, right? Or verify the inverses here. So I'm going to graph the inverse here. What do we know about inverses graphically, about x's and y stuff? What do we know about x's and y stuff? Ooh, reflect it. Yeah, and then kind of like a reflection about what? That's cool. That's a totally good question there. That's a deep in question, Dylan. So let's graph this guy. Let's make some graph paper here. All right, can you real quick here graph for me 2x minus 4? Can you graph for me that guy? All right, I think I'm gonna go 1, 2, 3, 4. I'm gonna be down here, is that right? Starting off -4, going up to 2, 1, 2, over. I'm gonna go here, 1, 2, over. I'm gonna be here. I think I have a graph that looks like this. Okay, tell me, agree, disagree? Okay. Let's put little dots in here. So let's see, this guy is, no. This guy is 0, -4. Everybody agree there? This is a 1. My pen is acting funny here. 1, -2. And my other dot is what? 2, 0. Perfect. 2, 0. And let's do a few more here. Can you guys give me this one, and this one? What are my dots here?
3, 2, 4, 4.
3, 2, 4, 4, and 5, 6. Okay. With a funny looking pen. How do we graph the inverse functions? Yeah, just switch the x's and y's. So I'm going to let you guys try that. Go for it. Can you switch for me the x's and y's? And let's see if we can. gonna change pen color here to black here. So let's go 1, 2, 5. So I'm gonna go with -40, -21, 20, 23, 02. There you go, 02. 2, 3. There we go. Ooh, 4, 4. That's interesting. Actually, should have been right here. 4, 4. And then 6, 5, right? So this little dot should have been in the same spot here. Okay. So Dylan, what do you say? It is reflective about what?
I was trying to figure that out. If you're trying to graph like 45 degrees to the left, you can see how it's reflecting.
Uh-huh. Yeah, then we can actually even go like this right here. Look at this. Doesn't that go to there?
Oh, yeah.
Because all these guys, the 4, 4 actually hits right on top of each other. That kind of gives us a clue. So the 4, 4, since they switch around, they still become 4, 4. But then this we call symmetric as well. 0, -4 going to -4, 0. That's technically symmetric about something. Arna, what do you guys say? So the clue is the fact that 4, 4 is symmetric about itself. Is that right? So that means wouldn't 3, 3 also be symmetric about itself? Wouldn't 2, 2 be symmetric? 1, 1, 0, 0, -1, -1, negative. There it is, -2. It's this little line right here that we see. And you guys remember a long time ago in the same classroom, it was called the identity function. It's y is equal to x. So if you were to fold that little graph paper on top of itself, right? With the fold right on y is equal to x, voila, you get yourself the red line going into the black line. Are we good? That's cool. Okay, so real quick here, if you want to write this in, you can put identity. It's called identity function. That's what it's called, identity function. So it is symmetric about the identity function. Okay, now real quick here, since you guys are sophisticated Algebra 2 students, can you give me the equation for this guy? What's the equation of the black line?
X equals 2y minus 4. Can we even do that?
Say again.
X equals 2y minus 4.
Oh, absolutely, Dylan. We're gonna get it in just a second here. Yep, that's the next thing to do.
Y equals 1/2 x plus 4.
I agree. So notice this real quickly here. That's a +4 this time, right? And then if you go up 1, you're gonna go 2 over this time to get to 2, what is it, to get to 3, 0, right? You're going from 0, 2 to 3, 0, 2 to 2, 3. Oh, sorry. No, 1 second here. Let me make sure that's correct. Yeah, that's right. You go 1 over, you go 1 up to 2 over. Abe, you said 1/2, is that right? 1/2 x?
Yeah.
Plus 4, is that right? Perfect, okay. Okay, how do we write this as the inverse function again?
-1 or something.
Perfect, yep, f negative 1. 1 half x plus 4. Are we good? All right, and then Dylan had a good idea. He says, look, I'm going to verbalize his good idea. As long as I can find my other pin. Okay. I'm going to see if I can redo my pins here as I'm explaining stuff. So hold on. If we did x's and y switch, right? So the 0, negative 4 switched with the switch to negative 4, 0, right? So hold on then. Dylan was asking this question. If you're switching individual points, hope I don't break it here. Can't you switch, no, tell me if I'm right. Can't you switch the variables themselves? See, that's what he was asking. He just did not know he was asking that. So now, example 3, we're going to do this. We're going to find the inverse function. Boom. As long as I can get my pin in here. Maybe it went like this. No, how to go like this. Let me do it this way. Ta-da, let's see. Oh yeah, everything's great now. Okay. Example 3. Let's find the inverse. Now we'll pull algebraically. Whew. How's that for a good word there? Algebraically. And let's do the same one, just so we can get a sense of this one here. So I have a function called f of x, and it is 2x minus 4. Find the inverse function. So what do? Let's see. First of all, we don't like it to be an f of x form. So first thing that we do is we switch the the f of x into a y. Because we like to work with x's and y's, not f of x and x's and y's. Okay, so now what we do. So this guy's the switch right here. And if you want to write it down, that's fine. So f of x becomes y. Next thing is we switch x and y. Now this becomes x, that becomes y. And next thing is solve. Solve for y. Hold on real quickly here. Let's go back to our little graph here. Something went wrong over here. Is there something wrong over here? I think it's this little 4 right here. On your notes, is it crossing at 4? Just go back in your notes real quickly here. I'm going to blame it on my pin not working well. But notice it's not crossing at 4, it's crossing at 2. So everybody okay with this? 1/2 x should have been plus 2. That's my inverse function from the graph. Okay? So go back in your notes real quickly here. Those are the pins. Oh, I'm so sorry. Camille, still good? Osmosis still working? Okay. All right, let's jam. So boom. So I'm going to do this here. I'm going to add 4 to both sides. So we're good. Adding 4 to both sides. X plus 4 is equal to 2y. Good there? What should we do next? Divide by 2. Let me switch the x's. Let me switch the equations around real quickly here. I'm going to put the y in front. X plus 4 divided by 2 here. And I think we're almost done here. 2 divides the x, leaving us with technically 1x over 2. And the 2 divides the 4, leaving us with that. And the question is that exactly what we had before? Sweet, we just found this guy algebraically. Okay, tough one for you guys. Ready? Last 5 minutes of class here. Tell me if I'm going too fast, okay? So B, all yours here, find the inverse for this function. A little bit more complicated, but that's okay. All right, give you guys maybe, let's see, I'll give you guys 30 seconds here, 30, 40 seconds, try it yourself. All right, I'm gonna try it here. So first things first, I'm gonna change the fx to y. Switch my x's and y's. Good there so far. And let's start solving for y. So multiply both sides by 2. Got myself a 2x is equal to 5 minus 3y. Perfect. Let's see, I'm going to subtract 5 from both sides. So 2x minus 5 is equal to negative 3y. Running out of space. And let me switch it around. Divide both sides by negative 3. And you know, the only thing is we don't like negative 3. We don't like negatives on the bottom. So here's what we're going to do is we're going to take this little negative, put down front. Okay, are we good there? Did you guys get that before I got that? Perfect. 1, 2, 3. Okay. Okay, so that's one way to answer it. We're good? Let me show you the other one here. This is the way the book answered it, just so you know. What they did is they multiplied the negative into the 2x minus 5. They didn't like the little negative hanging out in front of the fraction. That's okay. It's still the same thing. That's why I put or over here. And what they did then, they had this as one answer. And then they had, man, look at those multiple answers here. And they had this as the other answer. You talk to me. Are all those three? Last one? Okay. Did you multiply the negative into the top and switch them?
I added 3y to both sides like before.
Oh, okay.
Negative 1 and subtracted 2x.
Gotcha. Okay. Yep. Makes sense. Abe actually added 3y and then subtracted 2x. That's how you got it. Okay. Perfect. With an hour, oh, sorry, a minute and a half left here. Real quick here. C. Just a quick one. What? Charlie was reaching for his bag and I stopped him. Okay. Find me the inverse of this guy. So inverse of the cube root function of x plus 1. And we're totally on a time crunch. We have 45 seconds left. 44, 43, 42, 41. So I think I'm going to switch to this guy, to a y value. How do I undo cube root? Cube it. Perfecto. So real quick here, look up here if you have it. I'm going to do this guy to both sides. Boom. This becomes y cubed, and these two are going to cancel each other out.
Are we not finding the?
Oh, thank you. So y is equal to the cube root of, I was solving it already here. So x changed into here, y changed into here, and now we're going to cube both sides. Thank you, Abe, so much. So x cubed is equal to y plus 1. Subtract 1 from both sides. Oh, and then I didn't mention one last thing here. What we do is when we say, okay, this is the final answer, and I should have done it for the A and the B version. You guys ready? One more thing I forgot. Yeah, we're gonna say this guy is now f inverse of x, and then you just write down the same exact thing.
Isn't it x cubed or x cubed?
Man, cubed. See, rushing it, I messed up myself. Okay, we're out of here. And Maddie, you got the privilege of spraying down the desks. Good meal. See you later. Have a good
Thank
day.
you. What are inverse functions used for in like real life situations?
Absolutely.
Thank you.
See you. To undo the work of other functions here,
Okay.
or see if this thing is acting like this on this one, how is this acting here in order to undo the work?
Gotcha. Okay.
So,
If I wanted to get ahead, are we going back to 1.9 where I would be able to do that?
yeah, 1.9 is, we're all good to go. Just finished. Cool. Thank you.